Welcome! In this video, we will continue our unit on the Industrial Revolution by looking at how the Industrial Revolution spread from England to other parts of the world and continued to develop. Last time, we spoke about why the Industrial Revolution began in England with those four factors of production being present: capital, labor, market, and resources. We talked about how the commercial and agricultural revolutions primed the pump, so to speak, and got England ready for the Industrial Revolution. But the Industrial Revolution does not simply refer to one thing. It can sometimes seem vague and amorphous. Here I have what some historians would say are 5 different stages of industrialization. 2 through 4 are what we traditionally think of, but in a way it started sooner and is still going to this day as major changes in technology and machine use are constantly changing. So in stage 1, in a pre-industrial revolution, you can see the printing press, developments in seafaring and shipbuilding, increased digging of coal, the mechanization or partial mechanization of linens and wool manufacture dramatically changed in this period, and again, sort of primed the pump for the more serious industrial revolution. The period we're mainly talking about now is this stage 2, 1750 to 1850. The invention of the steam engine, the mechanization of textiles and cotton production, the prevalence of factories where machines and laborers were concentrated in order to efficiently and cheaply manufacture goods, and the widespread mining and refinement of iron and coal and the burning of coal. Stage 3 we think of, particularly if you study the Industrial Revolution in American history, this is really when the United States heavily industrializes, is in this late 1800s period. And it's when you see the invention of the steamship, railroads, the steam-powered locomotive, and the invention of the telegraph and its widespread use. You also see the invention of the telephone, but it does not become more prevalent until stage 4, where you see the invention of the dynamo and the ability to use electricity, the widespread use of the phone, the invention and increasingly widespread use of the automobile, the car, and the refinement and digging of petroleum or gas and oil on a widespread basis. Stage 5, though, also continues the Industrial Revolution with airplanes, aviation, the development and widespread use of aluminum, the development and widespread use of plastics, electronics, which is different from simple machines that use electricity, but electronics using computer chips and the sort, and also biotech, nuclear things. And then in some would differentiate and say that maybe we're in a stage 6, the information revolution or the digital revolution. Others would say that it's not a continuation of the Industrial Revolution, but rather a new thing all of its own. But keep in mind that, just like I said with the factors of production, how historians and books would disagree exactly on the way to define it, similar to the Industrial Revolution. Are these all one big phase? Are they separate? Should they be considered whole different movements in human history? It is a subject of debate. So let's get specific to this period we're talking about here, stage 2, with the development of machines to produce all sorts of goods that save on manpower and make things more efficient. One of the things that primed laborers to become laborers is something called the putting out system, where entrepreneurs, those hoping to manufacture extra textiles, again, cloth or cotton goods, would take the tools and the raw materials and put that work out to peasant farmers, people who lived in the near countryside to cities, and in exchange for doing that work on a regular basis, which the entrepreneur or his agent or whatever would go around and collect and then sell at a profit and would pay these peasants for their time. Remember, peasants kind of have an up and down season where sometimes they're planting, sometimes they're harvesting, sometimes they have downtime. And in that downtime, they would have this work put out to them, which they would do, and in exchange, have some money. This does 2 things, this putting out system, that further develop the factors of production. Well, you could say 3 things. One, it further builds the class of those with capital, right? The entrepreneur further gets more experience in investing capital to make a profit. It gives peasants a taste of being a laborer, of working for pay, rather than being a subsistence, self-contained farmer, as most peasants were, who made almost everything that they ate and wore and used. A high percentage of it they made themselves and did not engage in the wider economy. And on to that note, they also became an active market, because as these peasant farmers were paid for some of their work, they had money to spend, and therefore they became a market for machine-produced or goods that other people produced. Next, you see a explosion in hand-powered machines without even electricity, without steam engine power, without even having a water mill. You saw the growth of simpler machines that maybe are the size of a large loom, maybe smaller, like the Eli Whitney's cotton gin for separating cotton from its seed, which was smaller and could be carried around and put on a table and turned by a hand crank. And so you have hand cranked machines that could be brought out to peasant farms, but that's inefficient because the peasants aren't using it all day, and you buy these new expensive machines that are being seldom used. So it led entrepreneurs to construct mills, sort of a proto-factory, a place, sort of a warehouse where you would concentrate a whole bunch of machines and have workers come into them. Still no electricity, still not even a steam engine, and the original ones, there's still not even a water wheel. It's simply a place where you concentrate hand-cranked machines, and you would bring laborers in, and you could run the machines 24 hours a day, as long as you could get the workers to come in. And this was very efficient. Next, you see the development of water mills, where you would build a mill or a factory next to a fast-moving waterway, and the water would turn a large water wheel, which would turn a large main drive shaft that would then have its rotational energy transferred to a main beam or a drive shaft that would be up in the ceiling above where workers were working by their machines. And again, still no electricity, still no steam engine, but the machines would have cranks or levers that you would basically allow the machine, would have an arm going up with either gears or belts or pulleys that would engage the belt or pulley or engage the gear to the main drive shaft, and then the machine would run itself. And therefore you'd have one laborer, one worker, whose job it would be to manage multiple machines. You now no longer have someone turning a hand crank, but you can have one person with, say, 5 machines, and their main job is to load each one and turn it off if it gets jammed or if it runs out of raw material. And again, much, much more efficient than making everything by hand. Then you get the explosion. The most significant development in this period is the development of the steam engine. The original steam engine was built by Thomas Newcomen, and it was basically, it would burn coal to heat water. That water would drive a piston. That piston can be turned into rotational energy to drive a main drive shaft and engage machines, but they didn't do that at first. At first, they were using it as a pump. It could engage up and down motion from the piston, which would help pump out mines. So they could dig their mines deeper and deeper. It was James Watt who made the steam engine much, much more efficient and had the idea to attach a flywheel, thereby allowing the piston, which can only provide two-dimensional up and down or left and right motion, into, and really I guess is that one-dimensional motion, into sort of a two-dimensional motion, which was rotary, and it would turn a flywheel, which could then turn and rotate a main drive shaft that could be engaged onto other machines. For that reason, we still measure, one of the measures of power and electricity is in watts. We'll talk a little bit later about how the steam engine revolutionized boats. For a while, there was a transition period where many boats had both sails and a steam engine, but gradually steamboats replaced all other form of ship that would sail the ocean, and we still say sailing, even though they would be powered by a steam engine and could go against the wind, against the current, and much, much quicker. And again, another huge land innovation was the railroad locomotive. All this year, we've been talking about how waterways are to be treated as highways and not barriers for most of human history, because land travel was terribly, terribly slow and inefficient. The land railroad driven by a steam engine powered locomotive revolutionized land travel. And for the first time, you could actually travel on land at a reasonable speed that was much faster than a human could even walk. Again, there were some animals, but by horseback, again, was relatively limited, and the roads were often poor. So even going by horseback or horse-drawn carriage was extremely limited, and water travel was preeminent until the development of the railroad. Can't overstate that. And then the next big change in factories, so you could have the steam engine, which is a development. It didn't have to be placed by a river as a water mill did. Finally, you have electricity, where you can have a giant steam engine, which is essentially all most modern power plants are. Is they burn something to heat water, and it drives pistons. Along with many others, a man named Daniel Faraday invented the dynamo, and which I am going to struggle to explain, but I think using rotational motion and magnets, they are able to create a charge which they learned how to store and eventually to transmit. So, it used to be a factory or a mill was simply a building where you had a bunch of hand-cranked machines. Then they put those factories next to fast-moving rivers, where the river would turn a wheel, and therefore the workers didn't have to crank the machines anymore. The rotational motion from the river cranked all the machines. Then they no longer had to be next to rivers. They could be placed wherever they wanted. They simply had to have a steam engine. But the steam engine would belch out all the smoke from whatever they were burning, usually wood or, more efficiently, coal. Finally, with the development of electricity, you could have giant steam engine production plants where they would burn the fuel and drive the steam, drive the piston, rotate the magnets in the dynamo, and create electricity, which could then be piped through wires to all sorts of factories, all, many miles distant from a steam engine, even more efficiently. And so that is kind of a summary of the way that the Industrial Revolution progressed in those areas. Another key area that the Industrial Revolution really changed, and we'll see this to develop what we already talked about, is in transportation. If you go back far enough, in the period of absolute monarchs, you mainly had, cities had some streets, but connecting cities and connecting places, there were royal roads. Many of these were just, dirt paths that were impassable in bad weather. You eventually had some private companies and private individuals build toll roads, where they would, on their own, as an entrepreneur or a capitalist, would build a slightly better road than anything else that existed and charge a high toll for using it. But again, since they were so rare, many often paid the toll, primarily people who were selling things. It was very difficult to travel to just meet family or things. That was still very rare. Another innovation was effectively gravel roads, these macadamized roads, named after a man named Macadam, which it's weird to think of as an advancement in technology, because to many of us, we think of these as strictly old-fashioned, but these are effectively really good gravel roads. They would be elevated with an elevated bed of gravel so that all water and bad weather and precipitation would sort of flow through the gravel away from the built-up road, so that instead of being a sunken, muddy road where the road gets worn down, the road would be up above water and precipitation, because the water runs right through the gravel rock. And these were much, much better roads than anything that had come before. It sounds weird to think, but it's in other words, a gravel road that was well maintained and was much better than just driving over the dirt. You saw the construction of canals, especially with steamboats, but they would connect waterways with man-made canals. And then the two game changers when you apply the steam engine to transportation technology. In the United States, a man named Fulton built the first steamboat called the Clermont, which would sail up and down the Hudson River between New York City and Albany starting in 1807. With the advent of the steamboat, you begin to see countries engaging in geopolitics or competition over strategic steam refueling spots all over the world. And you eventually see the replacement of wooden sailboats with wooden steam engine boats with ironclad or iron-made metal steamboats. And the railroad is the biggest game changer, starting with the Manchester to Liverpool railway with called the Rocket, was game changing. And you really connected land territories for the first time ever. This is when you see the standardization of time around much of the world with time zones. And the railroad is a perfect storm. It needs steel and iron, but it also fuels industry with its demand and its more efficient collection of steel and iron. Thanks for watching.